Welcome, students, to Solving Quadratics Part 2, some special cases. And these are ones I want to point out to you because the SAT seems to love them. And I see them a lot on practice tests. So we're going to start with the difference of squares. And yesterday we were working on a problem. At least for me it was yesterday. For you, I don't know when it was. It might be the same day. Might be a week later. I don't know. But in the previous video anyway, we were looking at this problem, I believe, or it's simplified to that. It started out as this right here. This is my little note page. It started out as this problem, and then we kind of simplified it, combined like terms and so on, and we got this. Anyway, so we had solved it by adding 4 to both sides, dividing by 9, and then taking the square root. I want to point out another way to look at this. It's called the difference of squares. And that just means that you've got some value squared minus another value squared equals 0. And there's a really special way to factor these. Something that means you can avoid the quadratic formula, or it means you can avoid a bottoms-up factoring, or however you learn to do that kind of thing in Algebra 2. So, if you look at 9x squared minus 4, you might notice that 3 times 3 is 9. 3 squared is 9. So, you're going to try to write both terms as something squared. So, I've written 9x squared as 3x squared, with the square on the outside so that both the 3 and the x get squared. And then minus, and then 4 is really 2 squared. So when you see a quadratic like this, that's a squared term minus another squared term, go ahead and rewrite it this way. Once you've got it written that way, then the way to factor it is always the first squared term minus the second squared term times the first squared term plus the second squared term. And it always factors the same way. And just as a little aside, if you don't remember what the heck I'm talking about, you might have learned it like this, or you might have learned it with FOIL. But if you take, let me go ahead and do it with this so you can see. So I'm going to follow that same pattern and then come back over here. So I'm going to write these as factors. And I'm going to take my first squared term minus my second squared term times my first squared term plus the second squared term. Let me show you why that works. So you might have learned the box method for multiplying, or you might have learned FOIL, whichever one. It works either way. If you take this binomial times this one, and you go ahead and multiply them together, so 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. 3x times 2 is positive 6x. And 2 times negative 2 is negative 4. Then when you combine all that together, you end up with 9x squared minus 6x plus 6x minus 4. And these like terms cancel each other out. So you're left with 9x squared minus 4. So this original, so my original equation and my factored form are the same equation. It's just that once you write it in this form, first of all, the SAT, as I said, loves this. It loves asking you something like this and then saying, which of these binomials is a factor of 9x squared minus 4? Something like that. And if you know this difference of squares method, then you know the factors. You can get the factors really easily. Okay. But then to solve this, so these are the factors. If you want to actually solve that, you just take the first factor and set it equal to 0. And then take the second factor and set it equal to 0. And then solve both of those. So I end up with x equals 2/3 or x equals -2/3, which is the same thing that I got, again, for me yesterday, for you, who knows when it was, but the first video. Okay, so anytime you've got factors like this, it's already factored for you, you can just do what I did. Take each factor, set it equal to 0. Let's try another one. I know that x squared it's just x squared, but 25 is 5 squared. So then I'm going to take the factored form, which is the first squared term minus the second squared term, times the first squared term plus the second squared term. And then to solve it, I set each factor equal to 0. Because as I think I mentioned yesterday, when you multiply two numbers and get 0, one of them has to have been 0, at least one of them. You can't take like 1 times 2 and get 0 or something like that. It has to be 0 times something. So we know one of those has to be 0. And then you just solve both. And there are your solutions. Okay, let me just put one more up here. And you guys kind of see if you can start this out. So see if you can write this as something squared minus something else squared, just like this, or just like this. So take a minute to look at what I did, and then see if you can do it. Okay, hopefully you said it was 2x squared minus 6 squared equals 0. And then see if you can write the factors. Go ahead, look at what I did here, look at what I did here with these squared terms and how I placed them, and see if you can follow that same pattern. And hopefully you wrote something like this. Now it's okay if you put the 2x plus 6 and then 2x minus 6. It doesn't matter if you flip those. You can multiply in any order you want, as long as you have one of each. And then see if you can figure out what is your first step to solve it. Again, look at what I did here with each factor and what I set it equal to, what I did here with each factor and set it equal to, then do the same thing here. And hopefully you said something like this. I'm going to take each factor and set it equal to 0. And then solve each one. Then you end up with x equals 3 or x equals -3 as your solutions. So that's difference of squares. Now we're going to look at one more special case, and we're actually going to look at a kind of subset of it. We're going to look at perfect squares that have a leading coefficient of 1. That means that there's nothing in front of the x squared other than just a 1. And perfect squares are like this. If you have, let's say, ax plus b squared, something like that, that's called a perfect square. And it's always going to end up something like this. In fact, since I said our leading coefficient is going to be 1, we're going to pretend a is going to be 1 and go ahead and just work with it like that. So again, we're doing kind of a subset of the perfect square. So we're going to look at it like this. So you're going to get something like x squared plus 2bx plus b squared. So you're looking for a certain pattern where your last number is a perfect square and your middle term is the square root of this doubled. So let me show you an example of that. Let's compare what I got here with this. So first, look at that last term and think to yourself, what squared is 25? And hopefully you're thinking it's either 5 squared or negative 5 squared. And which one it is depends on this. If this is positive, choose the positive square root. If this is negative, choose the negative square root. So this is positive, so I'm going to ignore this one because I don't want a negative number. Okay, so 25 is 5 squared. Cool. So we want to make sure the middle term is this doubled. So we want to make sure that 10 is 2 times 5. And is it? Of course it is. Of course 10 is 2 times 5. So when you have that situation, that's called a perfect square. And the way you factor it is to get it into this format right here that I gave you. Which is this squared term plus or minus this squared term. And it's just, you're going to write a minus if it's a negative number and a plus if it's a positive number, that's all. So that's the factored form. And again, SAT loves this type of thing. They love to just give you a perfect square and see if you could recognize it. So, good idea to recognize. Let me go ahead and multiply this out for you again to show you that yes, this is the correct factored form. So if I were to take x plus 5 times x plus 5, do not distribute that exponent. It doesn't work that way. This is a plus sign. You can't distribute an exponent over a plus or a minus. Only over multiplication. So don't do that. You have to do it like this or you have to FOIL it. Anyway, x times x is x squared. X times 5 is 5x. X times 5 is still 5x. And 5 times 5 is 25. So when you put that all together, you get x squared plus 5x plus 5x plus 25. And my like terms combine to give me 10x plus 25. So this little dude here gets doubled. So this is our original equation right here. X squared plus 10x plus 25 equals 0. And this is the factored form. Once you get the factored form, you can avoid doing quadratic formula on this thing, because otherwise that's what you would have to do. So this is a lot nicer. This saves you a lot more work than this one does, to be honest. So you're going to take your factor, just like we did before. We took our factors, remember, and set them equal to 0. Where is it? There it goes. There it goes. Set your factors equal to 0. Set your factors equal to 0. Set your factors equal to 0. You can still set your factors equal to 0. It's just that this time, both of your factors are the same dang factor. So you only have to do it once. And then solve. Which means, by the way, it is one of those cases where your quadratic is hitting at the vertex at that point. So that's why there's only one solution. One real solution, I should say. Because we learned about a different type of solution, didn't we? We sure did. So you get one real solution and you didn't have to go through the quadratic formula. Now, perfect squares can be confusing to try to recognize, so let's try that again. Let's try another one. Here's our next example. So I'm going to put the form up here for you again. Again, we're only going to work with ones right now that have a leading coefficient of 1. So you are looking for something that is in this form. And whether this ends up being a plus sign or a minus sign depends on if b is positive or negative. So we're going to look at that next, because notice we have a minus sign here, and that's okay. Look at your last number and think, what times itself is 16? And hopefully you're thinking 4. But since this is a negative, you want to go with a negative 4, so that when you double it, it stays negative. And then just make sure that 8 is 2 times that number. And And of course it is, but of course I wrote everything way too big and too close together. So let me just make that a little bit neater. So you got your number squared is 16, and then that number doubled is the middle coefficient. So that's what you're looking for. And if you don't have that, then you don't have a perfect square. Cool? Okay. And again, that is how it's going to factor. Because when you take b times x, then you get that twice and you get 2b times x. So go ahead and write the factored form. X, and then this time it's going to be minus 4. So that when you get that middle term, it ends up negative. Okay, so this is the part that the ICT loves. And then go ahead and solve that. So just like solving any other factored quadratic, take your factor. In this case, there's only one factor, it's just there twice. Set it equal to 0 and solve. So you get one real solution, and again, this is a case where the vertex hits the x-axis. So you get one real solution. Let's do another one. You try this time. Look at that last term and see if you can figure out what got squared to get that last term. And be really careful. Hopefully you said negative 6 squared. If you said positive 6, you're close, but this is negative. And when you get that doubling in the middle where you take x times b and then x times b again, you want it to be negative in this case. And if you pick a positive 6 here, then this is going to end up with positive 12. And yes, negative 2 times 6 is negative 12, which is yay, great. Okay, so go ahead and get your factor. So look at what we did up here, look at what we did here, and see if you can do the same thing here. And hopefully you said something like this, x minus 6 squared equals 0. And then go ahead and solve. And again, look what we did on this whole video. When we had the factors, what would we do to then solve it? And hopefully you said you're going to set the factor equal to 0 and then solve that equation. And there's your one solution. Last example for this video. I picked this because for some reason the number 1 tends to throw people off. So just think to yourself, what times itself is 1? Hopefully you were thinking 1 squared is 1. Could also be negative 1 squared, but then you'd have a negative 2 here. So since this is positive, go ahead and go with the positive 1. And of course, if you double that, do you get 2? You sure do. And then try to go ahead and write your factor. Hopefully you said your factored form would be x plus 1 squared equals 0. And then see if you can figure out how to solve that. Okay, hopefully you set your factor equal to 0 and then solve that little mini equation. And you should have gotten x equals negative 1 as your solution. And so what does that mean about the vertex of this quadratic? Think about that. And hopefully you said that that means this quadratic is hitting the x-axis at the vertex. Kind of like that. Not drawn to scale. Alright, well this has been another sufficiently long video. Thank you for sticking with me. And that's going to be all for now. And if you're in my class, then you are going to be seeing some of these in warm-ups, and we'll talk more about how to know when to use each method, things like that. Let me know if you have any questions, and thank you for watching.